What if I told you that everything you've ever known, every person you've ever loved, every war ever fought, every song ever sung, all of it fits inside a tiny speck so small that from a few billion kilometers away, it is practically invisible? That speck is Earth, and today we're leaving it behind. Buckle up, because the universe doesn't just challenge your sense of scale, it destroys it entirely. Earth, where everything begins. We start here, home, a pale blue marble suspended in an endless black ocean. From the surface, the universe feels enormous. Mountains tower, oceans stretch beyond the horizon. Storms span entire continents. But Earth, in the grand scheme of what is out there, it is a grain of sand on an infinite beach. And yet, this is where every human story has ever unfolded. Every empire rose and fell here. Every love story, every discovery, every tragedy, all of it, right here on this fragile, beautiful rock. Now, let's leave it. The moon, our first humbling step. Our first stop is the moon, and already the distances start to feel uncomfortable. At roughly 384,000 kilometers away, the moon seems close enough on a star map. But consider this. If you jumped in a car right now and drove at a steady 100 kilometers per hour without stopping, not even once, you would arrive at the moon in over 160 days. 160 days, just to reach our own moon. And when you look back from there, Earth shrinks into a small glowing marble, fragile, quiet, and achingly beautiful against the infinite black. Astronauts who have stood on the lunar surface and turned around to see Earth have described it as one of the most disorienting and humbling experiences imaginable. Suddenly, everything that ever seemed urgent or important looks impossibly small. If the moon already does this to our sense of scale, what happens when we go further? The sun, 19 years by jet. Pushing outward, we arrive at the sun, the burning heart of our solar system, sitting about 150 million kilometers from Earth. Astronomers call this distance 1 astronomical unit, or AU, the standard ruler for measuring space within our solar neighborhood. Here is how mind-bending that distance really is. Light, the fastest thing in the known universe, traveling at 300,000 kilometers per s-econs, still takes 8 minutes and 20 seconds to travel from the sun to your eyes. If light takes that long, imagine anything slower. A commercial jet flying at 900 kilometers per hour. It would take approximately 19 years to reach the sun, non-stop. No turbulence breaks, no layovers. 19 years of flying, just to reach the star that is practically our next-door neighbor. And we're just getting started. Mars, decades away at jet speed. Next up, Mars, the planet we dream about colonizing. The planet we've sent rovers to, landed robots on, and pointed our most powerful telescopes at. At its closest point to Earth, Mars sits roughly 54.6 million kilometers away. At its farthest, when both planets sit on opposite sides of the sundae, that gap explodes to 401 million kilometers. The distance isn't even fixed. It is a moving target constantly shifting as both planets trace their orbits. Want to travel there in a commercial jet? You'd better pack a lot of patience. It would take you upward of 50 years. This is why every Mars mission is a logistical masterpiece. The rovers and probes we've sent there didn't just travel far. They navigated constantly shifting orbital windows, calculating the precise moment when Earth and Mars align just close enough to make the journey even remotely feasible. And even then, it takes months. 50 years by jet. Months by the most advanced spacecraft we've ever built. For our nearest planetary neighbor, Neptune, where sunlight takes hours. Fly past Jupiter's crushing storms, past Saturn's iconic rings, past the tilted oddity of Uranus, and eventually you arrive at Neptune. The last planet, the ice giant at the edge of our solar family. Neptune sits approximately 4.5 billion kilometers from Earth. Sunlight, racing at 300,000 kilometers per second, takes over 4 hours just to reach it. Think about that. By the time a ray of sunlight that left the sun this morning finally touches Neptune's atmosphere, you could have watched 4 or 5 movies, taken a long nap, had 3 meals. Light takes hours just to cross our solar system. And Neptune is still just the beginning of what is out there. Voyager 1, humanity's loneliest traveler. In 1977, we launched a spacecraft called Voyager 1. No human has ever traveled as far as this small golden probe. It has been drifting through space for over 4 decades, and as of now, it sits more than 22 billion kilometers from Earth. 22 billion kilometers. The farthest any human-made object has ever traveled. And in 1990, at the suggestion of astronomer Carl Sagan, Voyager 1 turned its camera around and took one last photograph of home. The result became one of the most profound images in human history. The pale blue dot. From 6 billion kilometers away, Earth appeared as a tiny faint speck, barely a pixel, suspended in a beam of scattered sunlight. Carl Sagan reflected on that image with words that still stop people in their tracks. He pointed out that every king and peasant, every saint and sinner, every hero and coward in all of human history lived out their lives on that pale, tiny dot. And that perhaps this image, more than any argument, should remind us of our responsibility to be kinder to one another and to protect the only home we've ever had. One photograph, taken by a probe we launched in 1977, and it might be the most important perspective shift humanity has ever experienced. The Oort cloud, the edge of our solar system. Beyond Neptune, beyond even Voyager's current position, lies a region so vast and so distant that we've never directly observed it. We only know it exists through mathematics and gravitational behavior. This is the Oort cloud, a theoretical shell of icy primordial objects that surrounds the entire solar system, like a bubble. It extends up to 100,000 astronomical units from the Sun. That is roughly 1.9 light-years. To put that in perspective, you would need nearly 2 entire years of light-speed travel, just to cross from the inner solar system to the outer edge of the Oort cloud. At the inner boundary of interstellar space lies the heliopause, the invisible border where the sun's solar wind finally runs out of energy and surrenders to the interstellar medium. Cross that line and you have officially left our solar system. The sun becomes just another star in the sky. Beyond this point, our sun cannot protect you. Its warmth cannot reach you. Its gravity barely holds you. And yet, the nearest star is still light years away. Alpha Centauri, our closest neighbor, still impossibly far. The closest star system to our sun is Alpha Centauri, a triplet of stars sitting approximately 4.4 light-years away. In raw numbers, that is about 41.3 trillion kilometers. 41.3 trillion kilometers. To our closest stellar neighbor, at this scale, the astronomical unit becomes useless. Astronomers switch to the light year, the distance light travels in 1 full year, because nothing smaller makes sense anymore. Now remember Voyager 1. That remarkable spacecraft we launched in 1977 that has spent decades becoming the farthest human-made object in history. Traveling at roughly 17 kilometers per second, Voyager 1 would take over 70,000 years to reach Alpha Centauri. Not 70,000 days, not 70,000 months, 70,000 years. Every civilization that has risen and fallen in recorded human history could play out. Twice, and Voyager still wouldn't be there yet. This is the distance between stars, and our galaxy contains hundreds of billions of them. The Milky Way, our cosmic home. Step back further, much further, and our entire solar system becomes a barely visible fleck within a vast spiral of stars, gas, and mystery. This is the Milky Way galaxy, our home on a galactic scale. The Milky Way stretches approximately 100,000 light-years in diameter. It contains hundreds of billions of stars. Many of those stars host their own planets, their own moons, their own stories, most of which we will never know. Now here is a thought that should genuinely unsettle you. Somewhere within this galaxy, centered roughly on Earth, exists what scientists call the human radio bubble, a sphere only about 100 light-years across. This bubble represents the farthest reach of every radio and television signal we've ever broadcast into space. Every episode of every television show, every radio transmission, every signal we've ever sent out, 100 light-years, in a galaxy 100,000 light-years wide. Any civilization living beyond that bubble, which is the overwhelming majority of our galaxy, has absolutely no idea we exist. We haven't even announced ourselves yet. Our entire recorded history hasn't even whispered loud enough to reach most of our own galaxy. We are, for all practical purposes, invisible. The local group, a neighborhood of giants, zoom out again. Beyond the Milky Way, space doesn't become empty. It becomes crowded with other galaxies, each containing hundreds of billions of their own stars. Our galaxy is part of what astronomers call the local group, a cluster of more than 50 galaxies bound together by gravity, spanning approximately 10 million light-years across. 10 million light-years, a beam of light leaving one end of our galactic neighborhood today would not reach the other side for 10 million years. Long after anything we know has ended, that light would still be traveling. The local group includes our own Milky Way, the massive Andromeda galaxy, which, by the way, is on a collision course with us, though that won't happen for another 4 billion years, and dozens of smaller dwarf galaxies swirling around them like cosmic satellites. Between these galaxies lies something extraordinary in its emptiness, the intergalactic void, silent, dark, unimaginably vast. A wilderness of nothing between islands of light. The Virgo supercluster, thousands of galaxies. Keep zooming. The local group itself is just one small neighborhood within an even larger structure, the Virgo supercluster. Spanning roughly 110 million light-years in diameter, the Virgo supercluster contains thousands of galaxies across at least 100 galaxy groups and clusters. Every single one of those galaxies contains hundreds of billions of stars. Every one of those stars may have planets. The numbers become so large they stop feeling like numbers. The Milky Way, our home, containing everything we've ever known, is a minor member of a minor group within this supercluster. We are not at the center. We are not particularly significant in its structure. We are simply here. Laniakea, our address in the cosmos, and yet even the Virgo supercluster is just one piece of something bigger. Welcome to Laniakea, a name drawn from the Hawaiian language meaning immense heaven. It is our home supercluster, a gravitational masterpiece of cosmic architecture, stretching over 500 million light-years and containing the mass of roughly 100 million billion suns. Laniakea is not just a collection of galaxies. It is a dynamic flowing structure, with galaxy clusters and superclusters all being slowly, inexorably pulled toward a single mysterious point at its heart, known as the Great Attractor. The Great Attractor is one of the most fascinating and unsettling concepts in modern cosmology. It is a region of space. We cannot see it directly because our own galaxy blocks the view, that exerts an almost incomprehensible gravitational pull. The Milky Way, the local group, the Virgo supercluster, all of us are being dragged toward it, slowly, constantly. We don't fully understand what it is, we just know we're moving toward it. Within Laniakea, everything we've discussed, the Milky Way, Alpha Centauri, the entire local group, the Virgo supercluster, are tiny threads in an unimaginably large cosmic web, the observable universe, and what lies beyond. Now, take everything we've covered, the Moon, the Sun, Mars, Neptune, Alpha Centauri, the Milky Way, the local group, Virgo supercluster, Laniakea, and understand that all of it, every single bit of it, fits inside what we call the observable universe. The observable universe stretches approximately 93 billion light-years in diameter. And here is where your brain might refuse to cooperate. Because the universe is only 13.8 billion years old. How can something 13.8 billion years old be 93 billion light-years wide? The answer is cosmic expansion. Since the Big Bang, the universe hasn't just been growing, space itself has been stretching. Galaxies aren't just moving away from us through space. Space itself is expanding between us and them. And in the most distant regions, space is expanding so fast that those regions are moving away from us faster than the speed of light. Which means we will never see them. Not because our telescopes aren't powerful enough, but because the light from those regions will never reach us. Those parts of the universe are gone from us forever. Not destroyed, just permanently out of reach, retreating endlessly into an expanding void. The observable universe, vast beyond anything human language was built to describe, might be nothing more than a tiny bubble within an incomprehensibly larger whole. The final thought. So, how big is the universe? Big enough that our entire planet is invisible from the edge of our own solar system. Big enough that our radio signals haven't reached most of our own galaxy. Big enough that the distance to our nearest star would take 70,000 years to travel with our best spacecraft. Big enough that there may be entire galaxies, entire histories, entire civilizations, entire stories that we will never know existed. Not because we didn't look hard enough, but because the universe is expanding faster than the truth can travel to reach us. We are standing on a pale blue dot in the outer arm of an average galaxy, in a minor cluster, within a supercluster, within an observable bubble that may be a fraction of what is actually out there, staring into an infinite dark and asking how big. The honest answer is this: we don't fully know. And somehow, that is the most magnificent thing of all.